Tilden mining process overview video. The Tilden Mine is an open-pit iron ore mine. The active mining operation covers approximately 3,500 acres, excluding the tailings and water recirculation basins. Located on site is a concentrator and pellet plant, where the iron is separated and concentrated, and iron ore pellets are produced and shipped to customers. The basic surface mining process consists of the following steps: exploration and engineering, drilling, blasting, loading, hauling, and dumping. Before mining occurs, the iron ore deposit is defined from exploration drill holes. These holes extend up to 2,000 feet below the surface and are spaced between 300 and 600 feet apart. From the drill core returned to the surface, geologists can map the deposit, and assays are made to determine ore quality and to measure physical and metallurgical parameters. The resulting geological model allows a pit to be designed and mining scheduled to economically expose and extract the iron ore. The first step of the actual mining operation is to break the rock. Tilden uses electric-powered rotary blast hole drills to drill patterns of 200 to 300 holes at a time. The drill holes are 12 1/4 inch diameter and 50 feet deep, and are designed in a grid of approximately 30 feet by 35 feet. Pattern designs vary among the different material types at Tilden, and are individually designed to cause the optimal fragmentation of the rock when blasted. The holes are then loaded with gassed emulsion bulk explosive. Electronic detonators are programmed to detonate each hole in precisely the right sequence, only milliseconds apart, but only one at a time. The blast is timed to maximize fragmentation of the rock while minimizing ground vibrations and airborne shock waves. Initiation of the blast is done wirelessly from a safe distance. Once the ground is broken, material can be loaded into trucks. Tilden utilizes multiple different types of equipment to dig the broken material and load trucks, the largest of which are electric rope shovels. The largest shovel at Tilden has a 60 cubic yard bucket which can load over 120 tons in a single pass, loading a 320-ton haul truck in 3 passes. This shovel is over 70 feet tall, with the operator sitting 33 feet above the ground. Tilden also utilizes smaller electric rope shovels that have a bucket capacity of 45 cubic yards or 65 tons. If the broken material does not have economic value, it is considered waste rock and is hauled to a waste rock stockpile. When possible, old pits can be filled with rock as shown here. Otherwise, the rock is stockpiled above ground level in stockpile areas surrounding the open pit. Track dozers will maintain the dumping edges, allowing trucks to safely and efficiently dump their load and return to the loading site. Tilden also utilizes a fleet of large front-end loaders to load trucks at the mining sites. These wheel loaders have a bucket capacity of 28 cubic yards, or approximately 50 tons. Because they are more mobile than the shovels, loaders can be moved around the pit day to day, mining ore more selectively, as required by ore blending plans. Tilden's primary hauling fleet consists of 320-ton haul trucks. These trucks have a payload capacity of 320 tons and are over 24 feet tall, 28 feet wide, and 50 feet long. They are powered by 3,500 horsepower diesel engines driving electric wheel motors, allowing the trucks to travel 35 miles per hour on flat roads. However, when traveling loaded uphill at full power, these trucks can only achieve 7 miles per hour. Iron ore is hauled to the primary crusher, where it is reduced to a maximum size of 9 1/2 inches in diameter in a gyratory crusher before being transported on conveyor belts to the concentrator. The actual crusher occupies 5 levels below the surface level dumping doors. The crushed ore is conveyed to a covered storage building, which is the end of Tilden's mining process. From there, processing of the crude ore is required to separate and concentrate iron, followed by pelletizing of concentrate. Pellets are shipped from Tilden to blast furnaces for production of steel.